Good day, viewers, and welcome to today's physics class as we look at NECO Physics past questions. Moving on to the first question. The first question says, which of the following is a scalar quantity? Which of the following is a scalar quantity? A scalar quantity is a quantity that has only magnitude but no direction. And the options that we have are velocity, acceleration, force, and mass. The first three options, velocity, acceleration, and force, are vector quantity. Why? Because they both have magnitude and direction. The only one there that is a scalar quantity is mass. The unit of force is dash. The unit of force was gotten from Newton's second law of motion, which says that what force is equals to mass times acceleration, and it is measured in Newton, which is the same as saying kilogram meter per second square, which is what Newton, and that is option B. Question number 3 says, a car accelerates from rest to 20 meters per second in 5 seconds. What is its acceleration? So in this question, they gave us that the car accelerates from rest. Whenever a body moves from rest, its initial velocity u is equals to 0 meters per second. And then it got to a new velocity v, which was given as 20 meters per second. And the time it took for this acceleration was given in the question as 5 seconds. Then they asked us to find the acceleration. We know, so acceleration is unknown. We know that acceleration A is equals to V minus U over T. This is the same as saying I have 20 minus 0 divided by 5, which will give me 4 meters per second square. And that is option B. Moving on to question number 4, it says that the moment of a force is the dash. The moment of a force is the turning effect of the force, and it is the product of the force and the perpendicular distance moved by the force, which means that you take the moment to the pivot, which is the same as saying that the moment of a force is equal to what? Force times distance. That is option B. Moving on to question number 5, it says, what is the work done when a force of 10 Newton moves an object 5 meters? So we know that they were asking us to find the work done, so work done is unknown, and we have the force as 10 Newton. Then we are told also that the distance in this question is 5 meters, and we have to find the work done. We know that work done is equal to force times distance, which means that my work done is equal to 10 times 5, and that will give me 50 joules. And that is option C. Moving on to question number 6, it says efficiency is calculated by, and the efficiency of a machine or the efficiency in any appliance is simply the total work output over the total work input times 100 over 1. So you express the ratio of your work output to work input in percentage. So what you have is simply saying that efficiency is equal to output over input times 100 over 1. So the correct answer to this question is option A. Moving on to the next question, which is question number 7. It says the SI unit of pressure is that. The SI unit of pressure was gotten from a scientist named Blaise Pascal, as he constituted or he proposed the Pascal law. So the SI unit of pressure is simply Pascal, and 1 Pascal is equals to 1 Newton per meter square. That takes us to question number 8. Question number 8 says the speed of sound is highest in dash. The speed of sound is highest in steel, because in air you have the speed of sound to be about 343 meters per second, and in water is about 1480 meters per second, while in steel is about 5800 meters per second. So it is highest in steel because the particles are packed together. So because the particles are packed together, the speed of sound can easily, the sound can easily travel from one particle to another, and hence it is what highest in steel, which is option D. That takes us to the next question, which is question number 9. It says the angle of incidence equals the angle of reflection in dash. This is the first law of reflection, which says that the angle of incidence is equal to the angle of reflection, and that is what? The law of reflection, which is option D. So that takes us to question number 10. Question number 10 says, what is the focal length of a concave mirror if the radius of curvature is 20 centimeters? So in this question, it gave us our radius of curvature as 20 centimeters, and we're asked to find the focal length, which is unknown. We know that the focal length of the concave mirror is equals to radius of curvature divided by 2. So this will mean that my focal length is equals to 20 divided by 2, and that will give me 10 centimeters. So the correct answer is option B. Okay. Question number 11 is the next question, and it says, what type of lens is used to correct short-sightedness? The lens that we use for correcting short-sightedness, also called myopia, is the concave lens. The concave lens. And the concave lens always brings the image in a diverging way. So the rays of light normally diverge before they get to the lens of the eye. So the correct answer to that question is option B, which is the word concave lens. That takes us to question number 12, which says a transformer works on the principle of dash. A transformer works on the principle of electromagnetic induction, which is simply the transfer of electric energy between coils through changing the magnetic field. So when it changes, when the coil changes the magnetic field and there's transfer of electric energy, it is what called electromagnetic induction, and that is the principle by which a transformer works. So the correct answer to that question is option B. So question number 13 says Ohm's law is given by that. They are simply asking for the formula for Ohm's law. And if you remember vividly well, Sir Ohm stated a law called Ohm's law, and he said that the current passing through a metallic conductor is directly proportional to the potential difference across both ends of the conductor, provided temperature and other physical quantities remain constant. What Sir Ohms was simply saying is that V is directly proportional to I, and that means that my V is equals to IR. So this is the formula for calculating Ohm's law. So the correct answer to that question is option A. There's also question number 14, which says the unit of electric current is dash. The unit of electric current is the ampere. The ampere is the unit of electric current, and the ampere can also be rewritten because if V is equals to IR, this can also mean that my I is equals to V over R, which can mean that I have what? Volts per ohms. So the ampere can also mean volt per ohm. We also know that Q is equals to IT, which means that my I is equal to Q over T. This can also mean that my current is also measured in a unit called what? Coulomb per second. So you can either use volt per ohm, coulomb per second, or you can simply say ampere, which is the unit of what? Current, and that is option C. So that takes us to question number 15, which says which device is used to convert AC to DC? The device that is used to convert AC to DC is the rectifier, and it uses diodes to do this. So the rectifier is the device that converts AC, which is alternating current, to direct current, which is what? DC. So the correct answer to this question here is option B, which is the rectifier. So that takes us to question number 16, which says which of these is a non-renewable energy source? Which of these is a non-renewable energy source? So this is talking about what? Energy that can be replenished. So when we say renewable, is replenishable. When you say not renewable, it means it cannot be replenished. Once it is used up, it is used up. So wind is renewable, solar is renewable, hydroelectric is also renewable. The only non-renewable energy source here is fossil fuels, like your petroleum products. They are fossil fuel, like your coal, they are fossil fuel, and they are what? Non-renewable, and that is option C. Question number 17, which says in an electric circuit, the current is the same in dash. Now, in an electric circuit, we have what they call the series connection and we have the parallel connection. Now, whenever you have a series connection, the current is always the same throughout the circuit. But in a parallel connection, the current divides itself into the numbers of parallel paths that there is, so that what the current that is passing through the component of the circuit are not the same. But in a series connection, the current passing through the components are the same. So in an electric circuit, the current is the same in series connection. So the correct answer to that question is option A. So that is also question number 18, which says the resistance of a wire increases with dash. The resistance of a wire increases with dash. Now, from resistivity, we know that what? Resistance is directly proportional to length. Resistance is directly proportional to length. That's why you have that your resistivity is equals to RA over L. So it is from this direct proportionality that we have what? This formula. So which means that what? As the resistance is increasing, automatically the length is also what? Increasing. So the resistance of a wire increases with an increase in length, which is what? Option C. So that takes us to question number 19, which says a fuse is always connected to the dash. Please note that when you are doing your wiring, your fuse must be connected to the live wire, because the essence of the fuse is to what? To bridge the current when there is what? Overcharge of voltage within the circuit. So it is always connected to the live wire, which is option C. So that takes us to question number 20, which says a radioactive element emits dash. What does a radioactive element emit? All radioactive element emits alpha, beta, and gamma radiations. So we have what? Alpha, beta, and gamma radiation, which is what? Option B. So that takes us to question number 21, which says the half-life of a radioactive substance is the time taken for dash. Please note that the half-life of a radioactive substance is the time it takes the radioactive material to divide up to half of its total mass, or to decay up to half of its total mass. So the half-life of a radioactive substance is the time taken for half the mass to decay, which is what? Option B. So that takes us to question number 22, which says in the AND logic gate, output is high when dash. Please note that in the AND logic gate, output is only high when both inputs are high. So whenever both inputs are high, automatically the output will also be high in the what? AND gate. And that is what? Option D. So that is also question number 23, which says, what is the energy possessed by a body due to motion? Whenever a body is in motion, the energy possessed by the body is called kinetic energy, because kinetic energy is energy due to motion, and that is option C. So that takes us to question number 24, which says, what is the frequency of a wave if its period is 0.1 seconds? So if the period of a wave is 0.1 seconds, so we know that our period T is equal to 0.1 seconds, 0.01 seconds, sorry. So we are going to find the what? The frequency. And we know that the frequency of a wave is equal to 1 over period. So this is the same as saying that my frequency is 1 over 0.01, which can also mean that I have what? 1 divided by 1 over 100. And that will mean that I have 1 times 100 over 1, which means that I have what? 100 Hz. So the frequency of this particular wave is what? 100 Hz, which is option B. That is question number 25, which says the electromagnetic wave with the shortest wavelength is dash. According to the electromagnetic spectrum, in the electromagnetic spectrum, the wave with the shortest wavelength is the gamma ray. The gamma ray has the shortest wavelength in the electromagnetic spectrum. So the correct answer to this question is option D. So that takes us to question number 26, which says, when a body is in uniform motion, its acceleration is dash. When a body is in uniform motion, its acceleration is dash. Now, when a body is in uniform motion, it means that that body does not change velocity. And if the body is not changing velocity, it means its acceleration becomes 0. As what? Acceleration is the what? Rate of change of velocity. And if velocity is not changing, automatically there is no what? Acceleration. And the correct answer to that question is option B. The acceleration becomes what? 0. So that takes us to question number 27, which says the unit of power is dash. The unit of power is dash. Now, we have option A says joules, option B says Newton, option C says watt, and option D says ohms. The first one, option A there, which is joules, is the unit of work. Option B, which is Newton, is the unit of force. Option D, which is ohms, is the unit of resistance. So the correct answer to this question is the watt. That is what option C. Question number 28 says, what property of wave allows them to bend around obstacles? What property of wave allow them to bend around obstacles? So the correct answer to that question is diffraction of wave. So when wave hits an obstacle, so if I have, let's say I have rays of light traveling this way, so this is a beam of light now, and then I have a thick block here. So if I put a small aperture on this thick block, immediately these rays of light hit this block, they won't just pass through. Instead, they are going to bend around it and form this form of wave around it. So the ability of wave to bend when they hit an obstacle is called what? The diffraction of wave. So the correct answer to that question is option C. So that takes us to question number 29, which says a current of 2 ampere flows through a 4 ohms resistor. Find the voltage. So in the question, they told us that we have a current I of 2 ampere and it flows through a resistance of 4 ohms. We are asked to find the voltage. So this question is based on Ohm's law. And from Ohm's law, we know that V is equal to IR. This means that the voltage V is equal to my current there is 2 and the resistance there is 4, and that will give me 8 volts. So the correct answer to this question is 8 volts, which is what? Option D. So that takes us to question number 30, which says the instrument for measuring current is dash. The instrument for measuring current is dash. The instrument that we use for measuring current is called the ammeter. It's called the ammeter, and that is option B, which says the center of gravity of a uniform rod lies dash. The center of gravity of a uniform rod lies dash. Now, this question is based on equilibrium of forces. And whenever you have a uniform object, uniform rod, uniform meter rule, the center of gravity is always at the midpoint of that particular object. So the center of gravity of a uniform rod is at the center of the rod, or the midpoint of the rod. So the options are at one end, wrong, at the center, at 1/3 its length, at the midpoint of the base, wrong, is at the center. So the correct answer to this question is option B. So that takes us to question number 32, which says, which of the following is used in fire alarms? Which of the following is used in fire alarms? In your fire alarms are devices or apparatus that are set up in buildings that will detect when there is fire, or that you hit when there is fire, so that the persons within the buildings can come out of the buildings. And when this device operates using what we call the bimetallic strip. So the bimetallic strip is 2 metals that are joined together, and when there is heat as a result of fire, they expand. So the fire alarms use what we call the bimetallic strip, which is what? Option A. Moving on to the next question, which is question number 33. It says, which law states that like poles repel and unlike poles attract? This is the law of magnetism. The law of magnetism says that like poles repel and unlike poles attract. You can see that in your magnet, and that is that for that question, which is what? Option C. So moving on to the next question, which is question number 34. It says, what happens to the resistance of a wire as the temperature increases? Please note that as the temperature increases, the resistance of the wire also increases. As a matter of fact, for every 1 degree rise in temperature, there is a 0.6 ohms increase in the resistance of a wire. So automatically, as the temperature increases, the resistance also increases. So there's an increase when there's increase in temperature, and that is option B. So that is also question number 35, which says, Which quantity has both magnitude and direction? So out of these options, which quantity has both magnitude and direction? The first option, the mass. Mass has only what? Magnitude. There is no direction. Option B, which is speed, it only has what? Magnitude. There's also no direction. Energy has only what? Magnitude also. There is no direction. So the quantity that has both magnitude and direction is force, which is what? Option C. So that takes us to question number 36, which says, what is the unit of momentum? The unit of momentum is gotten from the formula of momentum. Momentum is simply the product of mass and its velocity. Momentum is the product of mass. So momentum is equal to mass times velocity. So if momentum is mass times velocity, this is saying I have what? mv. And if I have that, it means that my momentum is measured in kilogram, which is the unit of mass, and what? Velocity is what? Meter per second. So the unit of momentum is simply kilogram meter per second. So that takes us to question number 37, which says, total internal reflection occurs when light moves from dash to dash. Please note that total internal reflection occurs when light travels from a denser medium to a less dense medium. So, when light travels from air to glass, air is less dense compared to glass. When light travels from water to glass, water is less dense compared to glass. When light travels from air, from vacuum to air, vacuum is the same thing as saying air. That's space. So when light travels from space to space, travel from air to air. So the correct answer to this question is when light travels from glass to air, which is what? Option B. Glass is more dense compared to what? Air. So when light travels from a denser medium to a less dense medium, total internal reflection occurs. So that takes us to question number 38, which says, the charge on a proton is dash. The charge on a proton is dash. Please note that the charge on a proton is equal to 1.6 times 10 raised to power minus 19 coulomb. And it is positive because it's what? A proton. So the charge on a proton is plus 1.6 times 10 raised to power minus 19 coulomb. And that is option C. So that takes us to question number 39, which says, the slope of a distance time graph gives dash. The slope of a distance time graph gives dash. So if I have a distance time graph, this is a distance time graph. So here I have my distance and I have time. So let's say this is the graph. If I draw my slope of this graph, and I'm to calculate the slope of this graph, we know that slope is supposed to give me change in the y-axis over change in the x-axis. So in this case, I have what? Change in distance over change in time. And we know that distance over time is the same as saying speed, which can also mean what? Velocity, because both speed and velocity are used interchangeably, except that one is a vector, the other one is what? A scalar. So the correct answer to this question in this case is what? Velocity, because there is no speed in our option. So the correct answer here is what? Velocity. So the slope of a distance time graph is what? Velocity. So that takes us to question number 40, which says, what is the primary cause of tides? What is the primary cause of tides? Option A says moon's gravity. Option B says the sun's heat. Option C says Earth's rotation. Option D says ocean current. Please note that it is not ocean current. Don't go and say because you have tides. When you go to the ocean, you see tides in the water, and then you think that it is caused by the ocean current. It is not caused by the ocean current. It is caused by the moon's gravity. So the moon's gravity is what causes what? A gravitational pull on the ocean waves. Hence, there's what? Tides. So it is caused by what? The moon's gravity. And that is option A. Question number 41 says, a body in equilibrium has dash. A body in equilibrium has dash. So whenever a body is in equilibrium, there is zero force acting on it, or the total amount of force acting on it can be resorted into zero. So when you resolve the amount of force acting on a body in equilibrium, what they're going to have is what? Zero. So there is what? Zero force. So when the body is in equilibrium, we have what? Zero force, which is what? Option A. So that takes us to question number 42, which says the energy stored in a stretch spring is dash. The energy stored in a stretch spring is dash. So when you stretch a spring, because that spring has moved a distance, so that energy must be energy in motion because you have what? Stretched it. So when you stretch a spring, the energy present in that particular spring at that particular time is kinetic energy, which is what? Option B. So that takes us to question number 43, which says thermionic emission is the emission of electrons due to dash. So thermionic emission is the emission of electrons due to heat. So when heat is casted on a metal surface, the electrons present in that particular metal tend to move. So the movement or the transfer of electrons from the metal surface as a result of heat, when it hits the metal, is called what? Thermionic emission. And that is what? Due to heat, which is what? Option C. So that takes us to question number 44, which says, which gas law relates pressure and volume at constant temperature? Which gas law relates pressure and volume at constant temperature? The gas law that relates pressure and volume at constant temperature is Boyle's law. Boyle's law. And in Boyle's law, that is how you discover that what? Boyle's law, we have what? V is inversely proportional to the pressure. So if the volume is inversely proportional to the pressure, it means that I'll be having that my volume is equal to your constant over your pressure, which means that my K is equal to what? Vp. That's why you have what? V1 P1 is equal to V2 P2. So this is gotten from what? Boyle's law, and that is option A. So that takes us to question number 45, which says the refractive index is the ratio of dash. The refractive index is the ratio of dash. So we have many formulas for the refractive index. We have formulas such as saying that the refractive index is equals to sine I over sine R. We can also say the refractive index is equals to speed in air over speed in medium, and so on and so forth. So, but in this case, we have the refractive index. Option A says speed of sound in air over speed in water. Option B says speed of light in vacuum over speed in medium. Option C says speed of light in water over speed in glass. Option D says angle of incidence over angle of refraction. So looking at all of this, option D is very wrong because it is not angle of incidence over angle of refraction. And funny enough, it's supposed to be what? Sine of the angle of incidence. So the angle of refraction, the sine, not just the angle. The sine of the angle of incidence to the angle of refraction. And it is not speed of light in water over speed of light in glass. That's comparing two different mediums together already. So the correct answer to this question is speed of light in vacuum, which is what? In this case, air. Air is a vacuum over what? The speed in a medium. That's what? Option B. That takes us to question number 46, which says, what type of mirror is used in a car headlamp? So in a car headlamp, what you have there is a concave mirror. So we have what? Concave mirror within the car headlamp. This is what? So that it can focus the beam of light. So it focuses the light to form what? Beams. So the correct answer to that question is what? Concave mirror. So that takes us to question number 47, which says a neutral atom has equal number of dash. So a neutral atom has equal number of protons and electrons. So the protons and electrons are equal, hence what? The atom is neutral and it is what? Balanced. So if the atom is charged, let's say, for example, I have what? Hydrogen, or let me say sodium plus. This is what? This is an ion. So because it's an ion, it means it has lost what? One electron. So automatically, the what? Protons in this particular atom here will be what? Higher than the electron by just what? One. So this is what? This is not a neutral atom, as it is what? Charged as a result of what? Loss of electrons. So when the proton and the electrons are equal, that particular atom is stable and it is what? Neutral. So the correct answer is what? Equal number of protons and electrons, which is what? Option A. So that is also question number 48, which says, what device stores electric charges? The device that stores electric charges is the capacitor. The capacitor is used for storing charges. That's why you use it in your pumping machines, so that it can store the charge that will be transmitted to the water pumping machine. So the correct answer to this question is option B, which is the word capacitor. Question number 49, which is the next question, says, the property of a body to resist motion is called dash. The property of a body to resist motion is called inertia. It's called inertia. And this was stated by Sir Isaac Newton in Newton's first law of motion, where he says that what? Every object will continue in a state of rest or uniform motion unless an external force acts on it, which means that this body will remain exactly where you have kept it. If you leave it for 10 years, it will remain there so long as no external force acts on it. And this is the property of the body to resist motion, and it's called inertia, which is what? Option B. So that takes us to the final question, which is what? Number 50, which says the SI unit of temperature is dash. The SI unit of temperature is dash. Please note that the SI unit of temperature is the Kelvin. We have many scales of temperature, but none of those scales of temperature is considered SI unit. For example, we have scales of temperature such as we have the Celsius scale. So we have the Celsius scale. We have the Fahrenheit scale. We have the Rankine scale. And finally, we have the Kelvin scale. So the Kelvin scale is considered the standard international unit of temperature. Despite the fact that we have other scales of temperature, this is the generally accepted scale of temperature. So we've come to the end of today's class. If you have any question, drop it in the comment section. And don't forget to subscribe and turn on your notification bell so that you'll be notified when we drop a new video.